Pancholi, Assistant Professor in LG Institute of Engineering and Technology in Department of Electronics and Communication. This video is about subject Digital Image and Video Processing. So friends, we are going to discuss regarding the subject image processing in this particular video. So now, here we are going to start the discussion regarding the wavelet and multi-resolution image processing. So friends, first of all, we need to have the idea about how the wavelet that is useful in the image processing. With that, we can also have the idea about what is a wavelet, and we are going to discuss regarding the uncertainty principles of the Fourier Transform and time frequency localization. So friends, we are going to discuss regarding what is a wavelet. So a wavelet, that means the small waves, and which are the mathematical functions that represent scaled and shifted or the translated copies of finite length waveform, and which are known as the mother wavelet. So in short, the wavelet, that means the small waves. How the wavelet that is useful in the image processing. So now the wavelet that is a mathematical function which is useful in the digital signal processing as well as in the image compression. And the wavelet compression that works, that is by analyzing the image and converting them into a set of the mathematical expressions that can be decoded by the receiver. So this way the compression, in the digital signal processing, this wavelet that can be used. So question is, what is a wavelet? So now here in the diagram, you can see in the diagram of A, which are the functions of the Fourier transform. As we know that we are using the Fourier transform for analyzing any of the signal, and that Fourier transform that gives us the output that is in the frequency domain. Now, this is the second diagram, that is the wavelet transform. So as we know that whenever any time series is there, we can convert them into the frequency domain by the use of the Fourier transform. So this gives us the details about the frequency, but sometimes it may not give us the exact frequency component at which particular time it will occur. So that is why we need to take the help of the wavelet transform. So this way the wavelet that can be used. So that is why we need to study about the uncertainty principles of the Fourier transform. So now which kind of the uncertainty? So in the time frequency analysis, there is a uncertainty principle that limits the ability of simultaneous attain high resolution in both the time and frequency domain. Few images are there in that doing the analysis, time domain analysis, we don't have the information accurately. If we need a high resolution image, so at that time we don't get the output. So that is why the some uncertainty is there in case of the Fourier transform, and it may not give us the proper result, and that is why we need to go for the next principle. So in the extreme limit, a time series is perfectly resolved in the time, but it won't provide the frequency content, and the Fourier transform that perfectly resolves the frequency content. But what is the drawback of using the Fourier transform? That is, it don't provide no information about where in time this frequencies occur. So accurate information if we want, then we should go for the wavelet Transform technique. So, what is actually the wavelet? So, wavelet transform that is used to analyze a signal or image into different frequency component at a different resolution scale. Mean multi-resolution that can be provided by using the wavelet. So, different frequency component, okay, and with the different resolution scale, if we will do, then our image, that is the high resolution image. So, this allows the revealing the images, the spatial and the frequency attributes simultaneously. So, uncertainty principle of the Fourier transform. Here you can see in the diagram that the first diagram, that is the time series of any image of the signal you can consider. Fourier transform of that gives us the frequency information. Now when the time and frequency both involved, that in case of the wavelet transform. So here we have taken the few portion, that is the delta x and delta t. Okay, delta f and delta t for the some time as well as the frequency part we have taken. Then we have the high resolution using this, and here for the multi-resolution, mean for the different value, the different scale that can be applied onto the image, and we get the high resolution image. So this is the figure of the illustration of the resolution, limitations and uncertainty in a time frequency analysis. Now, the spectrogram. This is spectrogram that resolves both the time and frequency information, but with the lower resolution in each domain, okay, that is illustrated in the figure that we have seen. So mathematically, the time frequency uncertainty principle that can be written by the following equation. So this equation, that is minus infinity to infinity x square fx square dx, integration minus infinity to infinity omega square f of omega square d omega, and that should be greater than equal to 1 upon 16 pi square, where x fx, they are the squared function. So the multiplication of this two, that should be greater or equal than 1 upon 16 pi square. So this is the equation that we have to keep in the mind while the uncertainty arises in case of the Fourier transform. So this is regarding the uncertainty principle of a Fourier transform, which can be helpful that why we need to go for the study of the wavelet transform. Now the next point is time frequency localization. Now what is the time frequency localization? So now as we know that the Fourier transform that creates a representation of a signal in the frequency domain, and the wavelet transform, what is the point? A wavelet transform creates a representation of the signal in both time and frequency domain. So that is by allowing a efficient access of a localized information about the signal, and this is the time frequency localization, which is defined as, it is defined as the Fourier transform of the product of the signal against a translate of a fixed window function. So fixed window function is there, okay, and it is the product of that function with the particular signal. So this way you can get the time frequency localization. Now the method that is used by which the time frequency content of the signal that can be measured. So that method was the Geber method. in this Geber method, okay, that is known as the windowed Fourier transform also. So it is defined as the Fourier transform of the product of the signal against a translate of a fixed window function. So multiplication by the window localizes the signal in the time, and hence the Fourier transform compute the spectrum of the signal localized in the time, and the magnitude square of the Geber transform, that is known as the spectrogram of the particular signal. So this way we can get the information regarding the time frequency localization of the signal, and we can multiply the window, okay, which is localized in the time, okay, and hence the Fourier transform, which will where we apply the Fourier transform, will apply the Fourier transform onto the multiplication of the signal with the window, and we are applying the function on that, and which will produce the output, and this magnitude square, okay, of the Geber transform, okay, that provides us the information regarding the spectrogram of the signal. So this is regarding the primary details related to the wavelet transform. So in future, okay, we will also learn about the few more things related to the wavelet and the multi-resolution technique. So thank you very much everyone. Keep watching LJIET Electronics and Communication for more updates in the video processing. So thank you very much everyone.